All right, our next speaker is Xuewei Wang, who is coming to us from the Data-Driven EnviroLab.
Hi, nice to meet you all. I'm Xuewei Wang from Data-Driven Lab, and we're the group associated with public policy and also Institute of Environment, led by Dr. Andrew Xu. We're the group of using data science and techniques and trying to find signals from large-scale and unconventional data sets, trying to provide environment policy solutions to address environment challenges and climate change issues. So today, I would like to share our latest study on urban heat island, and specifically talking about how citizen and machine learning aided high-resolution mapping of urban heat exposure and stress in Chapel Hill. So just a quick recap of what is urban heat island. Urban heat island is the fact that the urban area is hotter than their rural surroundings because there are high concentrations of impervious surface that observe heat. And the question is how we're going to measure it. Ideally, to measure the urban heat island, you would use the air temperature, for example, from the weather station, from the local like the air monitors, but the issue is for those type of like weather station is not available, is not well covered of the whole area. Usually, for example, Chapel Hill, there's only like 2 or 3 data points for the whole area. And that's how then for this problem that we turn into the satellite data, which is a top-down imagery that capture the ground surface, land surface temperature. So the differences between this type of the data is it measure the temperature at, I come here, so measure the temperature at this level, while ideally the air temperature should be very cool at our like 2 meter high or well, more about like 1 meter high at our like human activity level. So with this study, and back in 2021, Dr. Xu and the other research did the research on the urban heat island disparities all over 175 major U.S. cities and urban areas. And what we found from this research is that in majority of the U.S. cities, the people of color and people below the poverty line have a higher risk of exposed to the urban heat island compared to their counterparts. And spatially, we also found interesting patterns. Those triangles are the community of color, and they're exposed to higher, 97 of the majority cities, we found that people of color communities are exposed to higher urban heat island intensities. And interestingly, we thought this may be more severe in like the hotter area, but actually we found that the magnitude of this effect is most is highest at the northeast corner of the country. So as next, we're interested in say, what's the urban heat island effect look like in the individual level? Because the satellite data, the remote sensing imagery is a top-down data, which is not very sensitive to how individual feels. And that's how we turn into our study in Chapel Hill, where we trying to using a new techniques, which is called the pocket lab sensor. As you can see from the bottom picture, one of RA is holding the device for it, and this is using our study. So in this study, we're using the pocket lab sensor, which measures air temperature, humidity, and also geological location for every 1 second. And we map the air temperature and these data at 5 different locations in Chapel Hill, identified by the town of Chapel Hill that had higher extreme heat exposure. And for this study, we're interested in understanding, one, if citizen science can help us understanding the urban heat island effect. Second is, what are the predictors and drivers of urban heat island in Chapel Hill? And third is there any heat exposure disparities happening in Chapel Hill as well? Okay, and this is the data we are getting from the campaign back in 2021, which we had almost like 40 participants mapping 2 sessions. One is from 2 to 3 p.m., the other one is from 5 to 6 p.m. As we can see from the left, those are dark in the colors are really, the better is that the area that really bad is really hot. Based on the data we measure is almost more than 100 degrees in Fahrenheit on that day. Then that area, that corner is Franklin Street, where we are right now. It's pretty hot in the summer, and we're also surprised that it was really hot on that day. Then we're going to use those citizen science data to understand, say, if we can build a model to predict the likely air temperature and humidity of the whole area of Chapel Hill. So then we use the citizen science data and combined with other potential predictors, for example, land cover and NDVI. NDVI are two indexes derived from the satellite data indicating the coverage of vegetation and the impervious surface. The next also combine adding the land surface temperature from satellite and also the area imagery as the input data. So we built a model using with the random forest and XGBoost, trying to predict of the air temperature and humidity for the whole area. We got a really good result as the outcome, and also we found out for air temperature and relative humidity for both of these two models, the land surface temperature are the top predictors, especially for the ones that are on the monthly averages and also the image that close to our campaign date. Then with the trained model, we develop and we predict of the, like I said, the air temperature and relative humidity, which is in the middle and letter in blue, and also the humid index, which is an index as a proxy of how people actually feel under the shade. It is a function of both the air temperature and the relative humidity. On the top row are the 2 to 3 p.m. data, and on the bottom is 5 to 6 p.m. data. We found out from the 2 to 3 p.m., the air temperature is, for the Chapel Hill, is all over hot over the whole area, while in the later in the day, 5 to 6 p.m., the heat seems has more variety in their distribution. So similar patterns also found in the relative humidity and also the humid index. As next, we're also looking into, say, if the air temperature distributions are different on different land covers. So on the left is the temperature differences from or hotter or cooler than the tree classes. On the right is the land cover of Chapel Hill. Green area is the tree area, and while the pink color is the urban or built-up area. So we found out that overall, the urban or impervious surface area is about 1.2 in Celsius hotter than the tree area, which is kind of really hot on that day. And then we continue our analysis to see if this heat and air temperature are may distributed in differently in different social and demographic groups. So far, we really haven't found out a significant differences of the heat distribution among different social economic demographic, because these like demographic of Chapel Hill is more or less like uniform compared to other of the regions. Then we turn into income to see if this will be an indicator or the heat may distribute it differently versus the income. So as this plot shows that the ones at the top lighted in purple and at the bottom lighted in blue are the data from our study. The top one is humid index and bottom one is predicted air temperature from our data. And in the middle, the one has most changes is the land surface temperature is directly from the satellite data. So we noticed that the land surface temperature is much more sensitive to the income versus the other two data from our study. So this is kind of expected because the land surface temperature is, the top-down data, and this we think this might become an issue because the land surface temperature has been using so many studies, so many research about urban heat island, and we think this is might result in a overestimate of the urban heat island, while people are using that because there isn't enough available data at the our individual level of air temperature. So that's definitely calling for more data to having more granularity or more like individual level of air temperature data to really help us understanding what's really happening under the canopy at the individual level of what the heat distribution really is and how that may affect people. So as our study evaluates of what are the urban heat islands really happening in our area. So what are the effective interventions and solutions to urban heat island? Definitely, first thing is planting more trees. People love trees, but the thing is, tree takes time to grow, and also because the land use and land protected area, and also there's not always you can plant trees in anywhere you want. That is a lot of things. As far as I know, both of the three cities, Chapel Hill, Durham, and also Raleigh, they're having plans to planting more trees. And also, there's another really interesting intervention from the city of Raleigh I would like to quickly introduce. It's calling the Cool Roadways pilot project. I think it's really cool because they're trying to paint a road with a light color, with the material that's supposed, they can reflect the heat versus the road supposed to absorb the heat. So they help trying to see if this practice could help reducing the urban heat island effect. And also, you can also help contribute this and participate in our mapping session with our data-driven lab. So I put a QR code here.